Solid has been divided into crystalline solid and amorphous solid. Now, what are the crystalline solids? Now, the crystalline solids have got the constituent particles, or we can say the solid are made up of constituent particles. Now, these constituent particles are actually the atoms, ions, or molecules. So, when the constituent atoms or molecules or ions, they have got a regular arrangement in a three-dimensional space, it will be known as the crystalline solid. Now, what are the crystalline solids? The substances whose constituent particles, which can be an atom, it can be a molecule or an ion, are arranged in a definite geometric pattern. Pattern will be there. A regular arrangement will be there in three-dimensional space. Right? Now, let us take a simple example here, NaCl. So, in NaCl, this one molecule of NaCl, right, will consist of two ions, Na plus and Cl negative. So, when we have taken NaCl, sodium chloride, we are not going to take a single molecule. There will number of molecules will be there. So the array which has been there, or we can say the arrangement, how it has been arranged, Na plus Cl negative, Na plus Cl negative. It will be carried ahead, Na plus Cl negative. In the same way here, Cl negative, Na plus Cl negative. So you can see that there is a regular arrangement, right? The arrangement is regular. So it has been followed in a long distance and in the three-dimensional space, x-axis and y-axis and z-axis. Along the whole space, we will get the same arrangement throughout. So if this is the arrangement, we have got a regular pattern, it will be known as the crystalline solid, right? So we can going to study about the characteristics. So due to the regular arrangement or a definite geometric pattern or a regular pattern in three-dimensional space, they have a regular geometry, right? So regular geometry means that here the NaCl or any crystalline solid will consist of smaller crystals, and these crystals will have a definite geometry. Either they will be triclinic, monoclinic, right, or tetrahedral. They will have a definite geometry. So we have got the arrangement will lead to a regular geometry of the crystal or the small unit of the crystalline solid. Second is they are long range order solid. Now, what does a long range order solid means? That this arrangement, you can see that I have shown it by dotted line. This dotted line is actually showing the interionic attraction between the two charges, Na plus Cl negative opposite charges, right? And this arrangement we can make it in toward the left hand side also, right hand side also. So this pattern or this array, we are going to observe it throughout the space. So it is a long range order solid for a long distance. The same pattern will be observed. Third, due to the regular geometry, right, a definite pattern is there. They will have a sharp melting point. What does MP stands here for? Melting point. Right. So melting point, the temperature at which the solid is going to melt down. It will start melting. So there will be sharp melting point. A definite melting point will be there, because at that particular temperature all the attractions are going to be broken down together, because the order is definite here. Next, they have got high enthalpy of fusion. Enthalpy of fusion is also high and definite, fixed, we can say, right? Now here the important one which I want to tell, that the crystalline solid are anisotropic in nature. Now this is very important term, that what is anisotropy, right? So anisotropy, now here let us take through this diagram only, that if we any physical property, let it be the velocity of light only. Now if it has been measured in this axis, in this direction, right, the magnitude will be found to be different, and if it is measured along this direction. So if I have taken this as x dash, and this is x dash, if the velocity is along this v1, and when it is x y, that time velocity is different, right? So in isotropy we can say that it is a property by virtue of which the crystalline solid or the substances show the different magnitude of the physical properties in different directions. So when we are going along this axis, this direction x dash, the value of the velocity is going to be different, and if you are going along this axis, the value of the velocity will be different.